from the ground up. Ready?
No.
Okay.
It's like inverse factoring.
Well, first of all, let's just think. Quadratic formula actually comes from this. So does a bunch of other stuff. That's why it's important to know. Bunch of stuff comes out of completing the square. So complete means to finish, right?
Mm-hmm.
And square is a square, right? Like a square is like this. This is a square. But so is this, right? So what this really means is we're going to start with something that's not a square, and we're going to make it a square. Washa. I'm going to write a square for you. Oh, Edgar, you're going to like this. Ready, Edgar? This is tricky. I'm going to write a square for you. Edgar, I bet this might not be something you learned in. This might not be something you learned in high school. Completing a square. You might not have. You should have, but you might not have, because a lot of places just skip it. Yeah.
You should skip it too.
Oh no. I even teach it to my freshmen.
Oh, you can go see it.
Oh yeah. Hey, you know how many the passing rate for freshmen in the AZ Merit right now for the state is like 36%. Yeah. Do you know how many of mine passed? 100%.
Mr. Brown.
But we don't skip stuff because it's tricky. If I were to skip it because it was tricky, that would mean that I think you're not smart enough. That would be rude. You might like it because I don't have to learn something tricky, but it's kind of insulting. I believe in you guys, especially you, Alexa. You can't let me down. You're my favorite student. Okay, so Alexa, check it out. I'm going to write down a perfect square. It's not going to look like a perfect square, but it is. That's a perfect square. Because, here's what it is. This thing right here is the same as x plus 5 squared. X plus 5 squared equals that. Okay, we're gonna write a few, and I'm gonna show you some patterns. You're gonna look for, there's properties of perfect squares that we're gonna use to make something a perfect square when it's not. So another one would be x squared plus 2x plus 1. And then another one would be x squared plus 6x plus 9. Another one would be x squared minus, let's see. Oh, how about 8x plus 16? And let's see, another one would be x squared minus 12x plus 36, or 36, however you want to say it. And otro más, x squared plus 20x más 100.
That's 10.
Yeah. This would be x plus 10 squared.
6.
Plus or minus? It would be minus 6. This one would be
4.
x minus 4 squared
3.
and plus 3. Oh, and this one would be plus 1. Right?
Is 2 a perfect square?
So, well, you could have a x plus 2 squared would be that. That would be x squared, or x plus 2 squared. So the nice thing about perfect squares is they're the easiest to factor. What are you thinking, Alexa? I don't want to move on before you're ready.
All of these are perfect.
All of these are perfect squares because they're just a binomial squared, and if you were to multiply this thing out, that's what you'd get.
How do we get 10 from that? How do we get 10?
Ah, I'm glad you asked, because
5 squared, I know it's 25 the next square.
well, okay, now look, if you write this, I'm going to write it down, and
it's for 2, it counts for 2, right?
Well, yeah, I'm going to write it down, and when I do this, God's going to kill a kitten. Every time you do that, God kills a kitten, because that's not true. That's not true at all, because you're right, it's x plus 5 times x plus 5, and that's going to be x squared. The outside is plus 5, the inside is plus 5, and the last two make 25. That's where the 10 comes from. I'm glad you asked. So do you see now why the 2 is here? Because 1 plus 1 is 2. And the 3 is here because 3 plus 3, right? Negative 4 plus negative 4 is negative 8, but negative 4 times negative 4 is positive 16. Let's do one more. Let's do
Do like 7.
Positive or negative?
Negative.
I agree. How you doing with this, Edgar?
Sorry, what?
How you doing with this?
It's a good,
Okay.
it's a good table.
So far, so good, right?
Yeah. So,
Well, here's the thing. There's like a pattern, a relationship between all of the perfect squares. There's a relationship between this middle term, right, and this last term right here. And here's what we're going to call them. Like the first term, we're going to call ax squared plus bx plus c. So a is the first number, b is the coefficient for x, and c is called the constant. Alexa, did you know that before, like the a, b, and c thing?
Yeah, that's perfect.
Did you know that, Jose? Yeah. So there's a relationship between the b and the c for all of these perfect squares. Do you know what it is?
They're divisible by the same number?
Mm,
Or
yeah, they are. That's true. But here, I'll show you. Check this out. Oh man, I wish I had a post-it note.
I have a post-it note.
Yeah, let's see. You got one? Because this is going to be awesome.
Yeah.
I'm excited about this. Oh, I have. Oh,
You have?
I have an arrow one.
I have arrow ones too. You want this one?
That's beautiful. Thank you.
Yeah.
I'll return them. I'm only going to use maybe 17,000 of them.
No, you can have them.
I'll
I
probably
don't
just
use
use
them.
one. You don't?
No.
Oh, check this out. Here's the relationship. Are you ready? I put it on a post-it note. Here's the relationship for all perfect squares that are quadratic, right? Here it is. If you take half of b and you square it, it equals c. So b is the middle number, right? The coefficient of x.
Mm-hmm.
So half of b. So half of 10 is 5.
And square is 25.
5 squared is 25. Half of 2 is 1, right? 1 squared is 1. Half of negative 12 is negative 6. Negative 6 squared is 36. That's the pattern. Do you see what I mean, Jelly Bean?
Because that's compensating for the 2.
Yeah, that's gonna, yeah. Okay, so I wanted this on a post-it note because here's what's gonna happen. So this, I'll give you a second to write this down. This is a perfect square. This is the pattern for b and c. That's the relationship between b and c. Half of b squared is c. That's like a big, big deal. Okay. Edgar, you could get a tattoo of that if you wanted. Good.
Did you write this down?
I think that's I put it on a post-it note because we're gonna be using it a lot. Okay. Here's what we're gonna do next. I'm gonna give you part of a quadratic, and I'm gonna ask you to put whatever number needs to be there to make it a perfect square. So if we had x squared plus let's say 16x plus something. Or what if we had x squared minus $18x plus something. Or what if we had x squared plus
64, 81. That's 9. No. That's 18.
64, 81, 68.
That'd be 18.
so this is b, right?
Yeah.
Yeah.
So half of that is 8. 8 squared. I think it's 64 too. And if you factored that, that would be x plus 8 squared, right? So the whole reason we make we want perfect squares is because perfect squares are so easy to factor.
Well, that makes it very short.
It makes life easy, right?
It does.
Okay, so this one,
Taught me
half of 18 is 9. 9 squared is 81.
Mm-hmm.
This one, the clue, well, half of what squared is 81? 9. But, oh, wait,
So that's
It has to be 18.
18. Oh, X. Yeah?
See.
Okay. So you guys, are you comfortable with that? You want to take a minute and write down how you figure out what this is?
Yes, I am.
Because that's the key. Because what's going to happen is you have to figure that out a lot.
That's good. Are we gonna have perfect squares like that, but it's not a perfect square?
We're going to have not perfect squares, and we have to change them into perfect squares. That's where the trick comes in. Because so far it's easy, right?
Mm-hmm.
Yeah. And I also think that one reason that teachers skip this a lot is because they actually don't understand this relationship really well. And they try to teach it with a step. I didn't really teach you a step. It's just like that's the pattern. All right. So I think it would be best idea if I show you an example, but you don't try to write it down yet. Oh my goodness. It's all blurry. There we oh.
So would B equal C squared times 2?
It would be the square root
Would be equal to
of
square.
C plus 2.
I'm sorry.
Yeah. Yeah, so you're right. So B would equal the square root of C plus 2. No.
Times
Yes, times 2. And the C is the square root, but the 2 is just a 2, right?
2. Yeah.
So we could write that cleaner. We could write 2 times the square root of C is what B equals. That's true.
Yeah. True.
Yeah. Oh, I hate it gets all blurry.
Be what?
I
So
hate-
those are all the different possibilities?
Well, they are. Yeah, absolutely. The one this one's right here. This is the one you need to know. So here's what we're going to do. Let's say we had to do something like solve by completing the square. And let's say we had something that wasn't a perfect square. Let's say we had something like x squared minus 10x minus 3 equals 0. Actually, if it didn't even say completing the square, if it just said solve, it's not factorable. So with what we've learned so far, we couldn't do it.
No solution.
Right. But there are solutions. But we just don't know them yet. Yeah. What's the matter?
I lost some highlighters. I like highlighters.
You don't like Post-it notes, but you like highlighters.
Yeah.
Okay. Don't take her highlighters.
Like my eraser?
I do. It's very lovely.
Yes, well,
Okay, so you ready? You got to
Yeah.
focus on this one because it's like really, really subtle. We're going to solve by completing the square. And so the thing we really want to do is we want to make this,
True.
we want to make it a perfect square. Huh. So I have to make a decision. I have to see how much I trust you guys. Do I trust you to, like, understand the idea? Yeah, let's do that. We're going to go with the idea. You guys are smart. We're not going to do steps. I'm going to do the idea. Okay? What number would, like, if I were to just cover this number up, we're going to use one of these fancy Post-it notes. If I were just to cover that number up, what number would that have to be for this to be a perfect square?
25.
25.
25. Do you guys agree? Positive 25.
Negative.
Positive.
No, yeah, positive
Because
25,
negative 5
5.
times negative 5 is
Yeah.
positive 25. So I'm going to put it like this. Okay. Oh, that's a cool one. Watch, because this must be 25 right there. I'm going to put it a little closer. Man, these are like the best thing ever. The camera's not good, but, you know. So that negative 3 needs to be a 25. Yeah? Okay. So I can add something to this number to make it 25. What would I have to add, though?
22.
That would make it 19.
Oh, okay, it's negative.
Yeah.
28.
28. Alexa, do you see if I added 28 to this, then this would become 25?
If you added what?
28
Where?
to this number right here.
Well, that would be.
That would make it 25. It's 28 plus negative 3, right? That's actually what I'm going to do. I'm going to add 28 to it. But if you do it to one side of the equation, you also have to do it to the other, correct? So here's what I got. I got x squared minus 10x plus 25 equals 28. Orale. Do you see? Don't get worried about what's next. What next is actually pretty easy.
Okay.
So here's what we did so far.
So the 28, where did you get it from?
Where did I get 28?
Yeah.
You tell me, where did I get 28?
Oh, from the plus 3?
Why did I use 28 though?
Because you're adding 20. You're adding plus 3 to the 25.
So why?
Wait, say that again?
Oh, I thought you were adding plus 3 to the 25. That's
No,
what you said.
no, I'm not adding plus 3 to 25.
Oh, okay. So where did you get the 28 from?
This must be equal to 25 right here. This number right here has to be 25.
Oh, okay. So
If you have negative 3 and you add 28 to it, don't you have 25?
Yeah.
That's where I got 28.
Okay.
Because 28 plus negative 3 will give me
Alright, so
25.
it had nothing to do with that top number.
That's right.
Alright,
That's
okay.
right. Yeah, you see now?
Yeah.
Because I needed this to become a 25, and there it is. But
Why
what
did you put
So what's
completed
it
the
about
square? What was here?
Oh, because that's what I did. Because this is a perfect square on the left. Do you see? This. I'm gonna use. Oh, Alexi, like highlighters. Watch. You're in for a treat. You're in for a treat, kid. Check that out. Highlighted. That thing in pink right there is a perfect square. And the whole reason we make perfect squares is, I forgot.
Because they're easier.
They're easy to factor. They're so easy they could be like a punchline of a your mama joke. That's funny right there. What's that?
I'm doing everything. You're doing.
That's funny.
Yeah.
But do you see? Do you see? This is factorable, and that's what it is.
Not for the 28.
Well, check this out. Because it's a perfect square, we can actually use inverse operations now. There's only one x.
So solve for x.
We can solve for x, because we're solving by completing the square, right? So we can actually use inverse operations. We can actually do this right here, and it's the same steps every time. We can actually take the square root of both sides. Do you agree?
Get rid of that.
Because the square root of a square would just leave you with x minus 5. I don't want to go too fast. I want to make sure you guys get a chance to think about that.
Nah, that's good. That's good. I remember this.
You're good with that part?
No. Rewind.
Rewind? Well, watch. Washa. Ready? If you took the square root of 9, wouldn't that equal 3?
Yeah.
Because 3 squared is what 9 is. So if you took the square root of 3 squared, that's just equal to 3. When you take the square root of a squared number, you're just left with
yeah.
the radicand, right? Okay? So when I take the square root of this thing squared, you're just left with this thing. It's not the radicand. I misspoke a minute ago, but yeah. Good? And then that equals the square root of 28. I'm going to write something that might confuse you, but watch. Well, here. Before I write it down, let me show you this.
That's 5.
That's 5? Do you guys agree this is 5?
Yeah.
Yeah?
Yeah.
There's another answer.
Oh, let's see it.
5 times 5?
1 square?
Mm-mm. This asks a question. This is asking what number times itself equals 25. So if you don't look at the thing and you just think what number times itself equals 25, 5 is one answer, right? But what else times itself could equal 25?
1 times 20.
That's not the same
Oh.
number though. It's two different numbers.
Nothing.
Negative 5
Negative 5 times negative.
is positive 25.
That's the same as 5.
No, it's not.
It's almost.
If you
No,
put
it's
5 down,
it's completely opposite. It's like it's opposite, like the difference between being alive or being dead. They're not even close. They are as opposite as they can be. This is like having $5 or owing $5. Yeah, there
Yeah,
is.
but what I meant is it's the 5. It's the
There's
five
still
of
5.
Yeah,
You're right.
That's what
You're
I
right.
meant. It's still.
They're very related. They're opposite numbers, but 5 and negative 5. So, do you see, for square roots, the thing is there's always two answers. You have a plus and you have a minus. You have a plus, you have a minus. You have a plus, you have a minus.
Ew.
You have
Okay,
a plus,
so
you have
for
a
the-
minus.
All quadratic equations like this gonna have plus minus?
Yep.
Gotcha.
So
'Cause
what's this you wrote on the bottom?
You have a plus, you have a minus.
That's because 28 is not a perfect square.
Uh-huh.
You have
So
a
lo dejo así because it's gonna
Yeah.
be like a long decimal.
So if that 28 were to be, let's say, a 25,
Five? Yeah.
then you just put x minus 5 equals 5.
plus or minus 5.
Plus or minus 5? And it stays like that?
Yeah.
And that's the answer?
Nope.
You have a solve.
We haven't solved for x yet.
Oh, okay.
So we have to add 5, right?
Mm-hmm.
So let's add 5. So here's our answer. X equals 5 plus or minus the square root of 28.
Not bad.
There's more things we can do with this number, right? But we're going to get to those later because it's already a lot of information to even get this far. But
It's been
yeah,
20 minutes already.
I know it's crazy, right? Time's fun when you're having flies. No, that's how a frog says it.
It's been 20 minutes?
Yeah, Mira, watch right there on the. See it?
I want you to see it.
Yeah. So for today, for right now anyway, we're just going to get this far. We're not going to worry about anything after that. We're just going to get that far. So do you want me to do one kind of quick and you just watch and see how it goes, and then I give you one to practice?
Yes.
Would that work, Alexa?
Sounds good.
Okay, so watch. I'll even let you make up the numbers and the signs for me. So I'm going to start off with x squared. That part we kind of got, right? Okay, plus or minus?
Plus.
Plus. Okay, I can do one with an odd number, but you might not like it. So you tell me, you want and you can give me a really hard problem, I can do it, but you might not follow along. So if you make this an odd number, it's going to be difficult. If you make this number even, it's going to be easier. So you pick, like, which would you rather have? An easy example to watch or a difficult one? You get to pick, Alexa, I guess.
A difficult one?
You want to see a difficult one? It might really confuse
What page
you.
would it be?
I have no idea.
No, we're just.
I have no idea what page this
Right
is.
now it's what? It's still part of chapter 4.
Oh no, I have no idea. Just work with me. Work
Well,
with
no
me.
wonder because I've been looking for it and I don't
Well,
know
Yeah.
what to.
if the hard one's going to get confused, then the easy
I'm
one.
gonna do an easy one. So pick an even number.
Oh, an even number?
Even, yeah. That'll be easier. When
A
when
big
this one's
even
odd,
number
it's
or a
trickier.
small one-digit?
Whatever you want. Sky's the limit.
12?
12. Okay. And then what about the last number? What do you want it to be? It makes no difference at all.
12.
No. Is it negative?
It could be negative. Negative's easier. Well, negative's safer because you'll always
No,
have
you know
real
what?
answers.
Let's do
Okay.
positive as well.
Okay. Positive as well. Positive what?
And as we need one?
It doesn't matter. It doesn't make a difference. What number you want here?
49.
49.
Well, it's not even.
That doesn't matter. Equals 0. Okay, so we're going to do this one right here. We just made that problem up, right?
Yeah.
Okay,
Maybe
so
with the answers.
so watch, Edgar. This is where you're going to learn how to do this, I think. We're going to solve for x, right? We're going to solve for x. And we're going to do it by completing the square because this is not factorable. There's nothing that multiplies to 49 and adds to 12. Because if it was 14, we could, right? So here's what we're going to do. Watch how I do this. Watch how I do this.
It's 36, right?
Do you see what I did?
Whoa, whoa, whoa.
Watch. I'm going to show you. Watch. I know I'm doing it a little different. Do you see what I did?
Yeah.
But I messed it up because I was. There we go.
Yeah.
Do you see what I did now? Okay. What number has to go here?
36.
36, right?
What?
That would make it a perfect square, right?
Because
But if you add it to 1?
Because what?
Because half of 12 is 6. 6 squared is 36. Because
Oh,
this.
half of six. Yeah.
Because
Maybe
this.
the other formula.
Now, if I add 36 to one side, I also have to add 36 to the other, right?
Oh, it's the same thing.
So this is x plus 6 squared equals negative 13. It would be subtracting 13 either way, right? But this is it's a little more routine. You don't have to think as much. You don't have to do as much in your head. You got more evidence of any mistakes you would make so you can find it. So even though the first one we did in our head, I actually usually write it like this because it's super easy to make an addition error. So then x plus 6 equals the square root of negative 13, so x is going to be equal to negative 6 plus or minus the square root of negative 13.
What's the answer? X equals negative 6 plus or minus the square root of negative 13.
Correct. Now that's not a real answer, it's imaginary, but we're not worrying about that yet. We're just trying to be able to solve it.
Alright, we're just doing.
Yeah?
Where's the plus and the minus
One S1
of the
is for
13?
that. You know when it's really hard to find an S1 even.
Like you guys have done the quadratic formula before, right? Negative b plus or minus the square root of b squared minus
But I'm
4ac
saying
divided by 2a. You've done that before, right, Edgar? You've done that?
which one? That one? Yeah.
Quadratic
yeah.
formula? See the plus or minus?
Yeah.
That's why it's there. Because there's two answers to square roots. This is
The
where it comes
minus
from.
or the plus?
That's where the plus and minus comes from.
Yeah.
Now look, this thing right here, you see how it's similar to the numerator already? You see? It's very similar. And yeah, this formula comes from completing the square. Okay, your turn. Ready?
Ready.
Let's do x squared. Let's do minus 4x minus 9 equals 0.